Hi, my name is Chelan Ray Tigagarino, and I will be discussing about the part 2 of the surface drainage design. Surface drainage design. It involves the removal of excess water from the surface of the soil. So this is done by removing low spots where water accumulates by land forming or by excavating ditches or a combination of two. The importance of surface drainage is it prevents water from forming on low spots. It also it also prevents excess erosion in the surface drains. Land grading. Process of forming the surface of land to determine grades so that each row of surface slopes to a field drain. Land grading also for surface drainage consists of forming the landscape by cutting or filling and smoothing it to plant continuous surface. It is a one-time operation involving the transport of earth according to the specified cuts and fills based on the predetermined grades. So land grading for surface drainage differs from the leveling for irrigation in that drainage. No uniform grade is required. So here are the five things that need to be considered when land grading. Number one is overall layout of the irrigated area to be developed. There are technologies available for this to identify the gross elevation of the zone. The ideal layout is the field should be laid out as nearly rectangular as possible. And soil profile, of course, we need to know what type of soil that are graded, need to be graded because there are some good soil for the crop, so we don't need to grade that. And crop value, since land farming is an expensive operation, therefore, higher the economic value of the crops that would be grown, the higher can be the investment in the land development. And number four, of course, we need to know what is the proposed irrigation method for the drainage system that are going to be, graded. And lastly, is guidelines on earthwork. The maximum of about 1,500 cubic meter of earth being moved per hectare. So that is the ideal volume of earth that needs to be moved per hectare. Let the volume of cut be in excess of the volume of the fill by about 20 to 50%. This is to take care of compaction of the fill that occurs over time, shrinkage of the fill material, and losses during handling. There are a lot of method in calculation land grading. So first, we need to talk about the plain method. So this is the most commonly used method of land leveling design. The procedure involves first determining the centroid of the field and then determining the average elevation of the field. This is obtained by adding the elevation of all grid points in the field and dividing the sum of elevation by number of grid points. This is an example of the plane method. The elevation of the grid points selected at 25 meters interval are determined from a topographic survey for land leveling program. The elevation of points are as given below in the table. You see this part here, these are the stations and this part lines. So this per station and per line has 25-meter interval. The field is to have downfield slope of 0.2%. So we need to determine the elevation of the centroid of the field and formation levels at grid points and amount of cut and fill at each grid points. So this is the solution of the example. So first we need to get the elevation of the centroid. To get that, we need to add all the elevation of the station over the number of station. This is from the table in the previous slide. So we have the total number of 20 stations, and if we add up all the elevation of the 20 station, it is equals to 1947. So in order to get the centroid, we need to divide 1947.92 meters divided by 20. So this is the elevation of the centroid, 97.396 meters, and it is said that the field is to be given at zero point 0.2 slope at 50 meters from the north-south line passing to the centroid. The elevation of this point is zero point 0.1, and below the centroid. So it means now below the centroid it is 97.296, and up above the centroid it should be 97.496. So this part here is the centroid. 'Di ba I told you that na we need the layout as rectangular as possible so that we can get this centroid easily. This is just in the centers. So it is also said that below the centroid, which is this part here, is point 0.1. The difference is point 0.1 meter. So 97.396 minus 97.296. So minus point 0.1 is this, and above is 97.4496. So syempre we need to do this for it to have the desired slope for the water to flow. And this elevation is the finished elevation. So after the previous elevation, so this is the we need to get for the land grading. In Since we have the desired elevation for our grading, so in order to get the cuts and fills, it is computed by subtracting the original elevation from the desired elevation. So, for example, at station A1, this station, the original elevation is 97.3. It is subtracted to the desired elevation, which is 97.296. So it equals to negative 0.004. So these are the cut and fill given in this table. So this part in B line 1, it's positive 0.0396. So the positive signs indicates fill, while the negative signs indicates cut. So this negative 0.004 is it is to be cut, and this is to be filled. So these are the values for each station, each grid that needs to be cutted or filled. We already talked about the plane method. We also have example for it. So the next one is profile method. So this method of land leveling designs consists of plotting the profiles of the grids and then laying the desired grades on the profile. With this method, the ground profiles are plotted and a grade is established that will provide an appropriate balance between cuts and fills, as well as reduce hole distances to a reasonable limit. This method usually well adapted to leveling design of very flat land with undulating topography. So we will not be having example for this since this is not really used in compute in calculation of land leveling. The third method is the plan inspection method. In this method is a rapid method, although this method does not ensure minimum cuts and fills or the shortest length of all. However, it gives you quick estimate. This method is adapted to moderate flatland slope. So this is method is not ideal because we want to minimize the cut in fill up to 1,500 cubic meter per hectare. So we need to accurately estimate the earth that needs to be moved. So this is not so ideal. In the last method is the contour adjustment method. A balance between the cut and fill can be approximated by maintaining the proposed contour in an average position with reference to the original contour at the same elevation. We already talked about the design consideration for fill for the land grading. So this time we need to talk about the design consideration for the field drains. So number one, easements and right of way. So an easement in the right to use the land of one person for a specific purpose to benefit another's interest. And two, three, four, five is soil properties. This is the same the same like the consideration for the land grading. So soil properties, of course, we need to know the properties of the soil, its profile, system outlet. It's like the design, the irrigation design, topographic, the location, and the cropping strategy. So these are the things that needed to be considered for field drain design. And also field laterals. It is also called leach fields or leach drains. These are subsurface wasteland disposal facilities used to remove contaminants and impurities from the liquid that emerges after an aerobic. So there are four types of field lateral. So the most common is the pipe and gravel rock. Number two, chambers, easy flow gravelless, 1203 H ADS septic tank. So number one is the pipe and gravel rock. This is considered traditional laterals. Wastewater is distributed primarily by gravity via perforated holes at the bottom of the 4-inch pipe. Lateral field configuration can be trenches, beds, mounds. So what happened here in this lateral field is that the water passing through the drains gets, this is like a filtration system. So before the water to be seeped in the ground, it needs to pass these beds of rock, of gravel and rock, to get rid of those unwanted contaminants and to be filtered away and good for seeping in the soil. We also have chambers. It is a large open space for wastewater to migrate along the bottom. Chambers can vary in width and length. Lateral field configurations can be trenches, beds, mounds, likely installed with gravel and rock and approved geotextile fabric. Easy flow Graveles 1203H. So this is technology that consists of engineered geosynthetic aggregate modular design surrounding a 4-inch distribution pipe. Easy flow is also wrapped in netting and also has a geofabric centered along the top of each bundle. So if you're familiar with the filtration of an aquarium or of an pond, they use this type of, it's like a PVC plastic to filter the water. So, and the last one is the ADS septic tank. As you can see in the picture, it is intended to be installed without gravel. Effluent is dispersed via a distribution pipe and into a series of void pipes. The pipe is engineered with holes and slats, so it is with holes for letting the water flow. So we already talked about the consideration for surface drainage and the lateral fields. So that's it. Thank you for listening.